Have you ever wondered why quantum computers are so incredibly hard to build? We hear about them solving problems in seconds that would take supercomputers thousands of years. So why don't we have one on every desk? The answer isn't just about building the chip. It's about keeping that chip quiet. It's about a concept called coherence. If a quantum computer is a Ferrari, coherence is the fuel. Without it, you don't have a supercomputer. You just have a very expensive, very cold paperweight. Let's break down what coherence actually is, without the confusing math. To understand coherence, we first have to look at the qubit. A normal computer bit is like a coin lying flat on a table. It's either heads, 0, or tails, 1. That's it. But a qubit? Imagine that coin spinning rapidly on its edge. While it's spinning, is it heads or tails? It's technically both at the same time. This is the quantum state of superposition. Coherence is simply the ability of that coin to keep spinning. A coherent state means the coin is spinning smoothly, undisturbed, maintaining that magical mix of heads and tails. As long as it's coherent, we can use it to calculate. Now, let's get a little more technical. In the quantum world, particles act like waves. Think of an orchestra. If every violin player is reading the same sheet music and playing in perfect rhythm, the sound is clear and powerful. That is coherence. The waves are in phase with each other. Because the waves are synced up, they can do something called interference. They can combine to amplify the right answers and cancel out the wrong ones. This wave interference is how a quantum computer actually thinks. But this state is incredibly fragile. This brings us to the villain of the story, decoherence. Remember our spinning coin? Imagine if someone bumps the table, or a breeze blows. The coin wobbles, loses its spin, and falls flat. It forces the coin to choose, heads or tails. In a quantum computer, that breeze can be anything. A tiny vibration, a stray Wi-Fi signal, even a little bit of heat. When these things hit a qubit, it loses its rhythm. The orchestra stops playing together and starts tuning their instruments. The quantum wave collapses into a boring, classical bit. That is decoherence. Once that happens, the calculation fails. This is why you see pictures of quantum computers looking like giant gold chandeliers. Those are actually refrigerators designed to keep the chip colder than outer space, near absolute zero. They are trying to create a world with zero noise and zero heat, just to keep that coin spinning for a few microseconds longer. So, coherence is basically the survival time of a quantum calculation. The longer we can keep it coherent, the more powerful the computer becomes. Thanks for watching. If you want to understand more about how these machines work, hit that follow button.